In this video, I'll demonstrate how to prepare a dataset before creating a linear regression model. So on line 1 of this example code, I bring in the dplyr library because we're going to use a few of its functions in this demo. So I'll call library dplyr to load the library, and then I call the dplyr glimpse function to look at the dataset we're going to be working with. And this is the built-in air quality dataset. So this air quality dataset contains 153 observations and 6 variables. And those variables are ozone, solar.r, wind, temp, month, and day. But this doesn't tell us a whole lot about what this data set is. Now, we know what the variables are and know what the observations are, and we have the types, so int, int, double, int, 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 and some of the values. But what are we working with? Well, this is a built-in data set, so we can call help of air quality, and it will load the R documentation for this data set. So these are New York air quality measurements. These are daily measurements from New York from May to September 1973. So what this is showing is the ozone in parts per billion, the solar radiation in Langleys, wind in miles per hour, the temperature in degrees Fahrenheit, and the month and day that they were recorded. So the month will be a number from 1 to 12, and the day will be a day of the month from 1 to 31. Now what I'd like to look at is the relationship between wind and ozone. So does the wind speed have any effect on the ozone's parts per billion? Well, before we start to look at a relationship, we need to clean up the data. So we need to prepare the data. So the first thing I'm going to do is look for NA values. So on line 6, I call any NA of air quality, and that returns true. Well, the columns or the data points that I'm concerned about are the ozone and wind columns. Now, are there any NA values in those columns? Well, on line 7, I call any NA of air quality $ozone, and that returns true. So we're going to need to filter those out. On line 8, I call any NA of air quality wind, and that returns false. So the wind values are fine. So now on line 10, I create a new data frame, a dplyr tibble called air, and I assign that to air quality. I use the dplyr pipe operator, so % greater than %, and I pipe our air quality data frame into the filter function. And to the filter function, I pass is.na ozone equals false. So I'm comparing that the is.na of ozone to false. So if we get anything other than an NA value, then we want to keep that record and include it in our air data frame. So we drop any records where the ozone is NA. So I'll execute lines 10 and 11 and create that new data set called air. And this has 116 observations of 6 variables. So there's still a fair bit of data to work with. And now as a sanity check, we can take any NA of air $ozone. Now remember, from this point on, we're working with the air data frame and not air quality. So any NA of air $zone is false, and any NA of air $wind is still false. So we have a data set that's ready for the next steps. Now, one thing we can do when we're preparing the data is get a sense of some values by using the summary function. So on line 16, I have summary of air $ozone, and that gives me the minimum value, so 1 part per billion, the first quartile, the median, the mean, the third quartile, and the maximum, which is 168 parts per billion, of our ozone data. And we could do the same thing with wind as I do on line 17. So I have summary of air $wind, and that gives me a sense of what I'm working with the wind variable. So we have a minimum value of 2.3 miles per hour, a maximum of 20.7, and a mean of 9.862. So this gets us to a point where we can start looking at the relationship between wind and ozone and create a model of it. And that's covered in the video titled Creating Linear Models. And that concludes this demonstration of some important first steps in data preparation before creating a linear model.